I was at an Earth Engine conference at Geographic in Dublin in late September, and there were like 2 people were like, "You visualize stuff in R." It's like, well, why? You could do it, but you know, you want to.
Hello, everyone. Welcome to the last day of our Geospatial week. Yeah, it's Friday already, and thank you all for people that has been here since Friday and people that are joining since Monday and people that are joining today. So, this morning we'll be having an amazing student session with Dr. Emil Cherrington, and he'll be talking about land cover change and vegetation by estimation. So I would like to give you a little introduction about him, and then we can pick it up. So Dr. Emil Cherrington is a research scientist at the Health System Science Center of the University of Alabama, Huntsville, Alabama. So he also served as the regional science coordination lead for West Africa for the NASA SERVIR program, SERVIR program. The SERVIR program is a joint initiative with NASA and the USAID, and they provide geospatial solution for organizations and different countries ranging from countries in Asia, Africa, and Latin America. And he had his PhD in forest ecology from the Agro Paris Tech in France and Technische Universität Dresden, which is in Germany. It's good to have somebody from the European Commission here. And he got a master's degree in forest resources from University of Washington, and then his bachelor's degree in biology from Loyola University, like that. So let's have here. Thank you.
Thank you for having me. Thank you for the Center for Geospatial Analytics for the invitation to the NC State University. It's my very first time in Raleigh. It's Friday. I don't see a whole bunch of people drinking coffee, so I assume that everybody's doing all right. Well, except John. Maybe it's me. And so just again, yeah, thank you so much for the invitation. I have a talk later today. I was asked if I wanted to also do a studio activity. Yeah, I'm always like nervous around like new people or whatever, and at least for right now, you folks are new for me. And one thing in speaking to Rebecca and Stelayo, thought about, well, how about using Google Earth Engine for doing things like looking at land cover change and also height estimation. And so just to kind of give you an idea of what I have planned, and said planned, which is why over there I kind of said, well, will we really get to cover everything? But the idea is to at least, kick us off with a little, well, I figured I'd like to be a little participatory, hear a little bit about, kind of who's in the room. But after that, talk about some theory regarding this algorithm, which is called LandTrendr, which was developed by Professor Robert Kennedy from Oregon State University. We'll do an exercise with that, so you get your hands dirty with Earth Engine. After that, we'll have a Q&A. Rebecca and Telayo suggested we take a small break so that we can kind of recover. And then after that, look at vegetation height using spaceborne LiDAR, and then an exercise. And then after that, close us off with another Q&A. So that's the general idea. And I have a rule. Long time. Yeah. I like to, kind of like, please feel free to stop me and ask a question, that kind of thing. Because I think too, like, we'll all get the most out of it if we, kind of keep it informal. So, I guess I'm standing here. Y'all have heard my name. I'm just kind of curious if we could just do a quick kind of around the room, just folks' names and maybe what you're working on. We'll start with John. Put you on the spot.
I'm John Vogler, a researcher at the CGA. I also coordinate the Geospatial Forum. When I'm doing research, I am interested in urbanization and land change, forest fragmentation, maritime forest mapping currently. And I do a little bit of administrative work at the center as well.
Hi, I'm Amelia. I am in the Masters of Landscape Architecture, and I'm interested in pursuing the GIS certification here at NC State. So I'm excited to learn more. My name is Liliana, and I'm also in the Landscape Architecture Master's program.
I'm Evan. I'm a first year PhD student interested in mapping the spread of agricultural pests.
But not using Q or ARC or.
Not yet, that we know of.
I'm John Polo. I'm a PhD student in the program here, and I study the spread of crop disease. And I work mostly in R as well, although I've done a little bit with Earth.
Awesome.
My name is Jimmy. I'm a grad student in college here, and I work with R, and I use R map biomas. That's a platform that connects with Earth.
Awesome.
Hi, I'm Lottie Cherrington. I'm a second year PhD student here. And I'm working on fusion of LiDAR GPS data for active planning.
Awesome.
Hey, everybody, I'm Ross Wintermeyer. I direct the Center for Geospatial. I'd love to talk to you guys about the certificate of graduates. Just looking at it.
Hey, I'm Tom, postdoc at CGA. Broadly, my work uses remote sensing to identify hosts for pests and pathogens spread upon.
I'm Varun, third year PhD student at Center for Geospatial Analytics. I work with understanding the linkages between greenhouse gas emission, agriculture, and flooding in Bangladesh.
And Varun and I know each other from his previous life with SERVIR Hindu Kush in Malaya, where he worked at the International Center for Integrated Mountain Development, or ICMOD, which is a center of excellence based in Nepal.
Hi, I'm Eli. I'm a PhD student here at the center, and I study models and analyze models for predicting the spread of invasive species.
Hi, I'm Avail. I'm a first year PhD student, and I'm interested in using remote sensing for flood mapping.
Hi, I'm Kelly Van Wozek, and I'm a first year PhD student, and I study impacts on coastal water quality from sea level currents.
I am Sumi. I'm a first year PhD student as well, and I study flood forecasting. It's more really hydrologic model, but it's like I want to use satellite image or data to enhance the model.
Hi, my name is Titilayo, and I am using remote sensing and machine learning to understand coastal forestry.
I'm Rebecca. I'm a third year PhD student at CGA, and I use satellite imagery to map urban flooding. I'm looking forward to mapping vegetation height and biomass now.
Awesome. Thank you so much. And just looking at my little guesstimate of the time, and we're before 9:15, so I guess I didn't plan too badly. But no, also for me, just as a professional and getting to go to other places and stuff, it's always useful for me to kind of take the pulse of like who's working on what, or what are the things people are working on. I was just remarking to John that I really appreciated seeing all the PCs in the room, with the exception of a few Macs in here, and finding out about folks who are using non-traditional software for their mapping and visualization, like R. So cool. How many people in here have already opened up Google Earth Engine at least one time in their lives? You all love Google Earth Engine?
I'm terrible with JavaScript.
All right. Do you do more of the Pythons out of it?
I'm almost all in R, dude. So Python's barely much more help.
If I could give you a little bit of my own life story. So when I was doing my PhD, I started off using R, only used R and Python in my PhD, and then eventually when I started working for SERVIR after my PhD, that's when I got into Java and JavaScript, and I found it easier than R. So it's I didn't find it was crazy. And what I really liked about Earth Engine is the things that you're able to do, whereas you don't have to download volumes and volumes of data onto your machines to do stuff. But of course, most of you folks, I think, are here at the CGA, and so I'm sure that you're exposed already to, big data concepts, et cetera, and so probably some of the stuff we're gonna look at will be 100% new for y'all. So yeah, okie dokie, land cover change. So Varun's probably already seen the slide like a bunch of times. Maybe the new part for Varun would be the lineup of logos on the bottom of the slide, which is to say that in terms of my background for where I work for, I support the SERVIR program on the NASA side. SERVIR, I'm not one of the people who like reads all the words off of the slides. I meet those kind of people every now and again though. Kind of awesome. So SERVIR is a partnership between NASA and USAID, or the US Agency for International Development. Also partnering with leading organizations like ICIMOD, where Varun is coming here from, as well as other centers that are listed down on the bottom. And we do stuff. What kind of stuff? Stuff in 5 different thematic areas. So ag and food security. It's not in alphabetical order. I didn't make the slide. I don't know why it's not in alphabetical order. I hope my superiors go hear that part when this is recorded and put out there. Agriculture and food security, ecosystem carbon management, air quality and health. Okay, I'm not going in order either. And water security and weather and climate resilience. Just kind of curious, Varun, the work you were doing at ICIMOD supported which of the thematic areas?
Agriculture and food security.
Awesome. And then now you're talking in methane and whatnot. So hopefully what you're doing here is building off of what you're doing before. But just to say, so even though I came to the SERVIR Science Coordination Office, as it's called, at NASA in Huntsville, Alabama, about 8 years ago. I actually, back in 2006, started off with the SERVIR program when it was only in its second year of life. And SERVIR started off looking at stuff regarding land cover change. And so just one of the things I'd like to put out there, stuff that we were working on at the center that I used to work for, called Cathalac, which is based in Panama. We were taking, data from Landsat and MODIS, and then generating land cover maps. This was circa 2010. But just to say that, folks might be aware that there are now like a whole lot of global land cover products, et cetera. But one of the, criticisms of global land cover products oftentimes is when folks kind of zoom into different regions or countries, they find that they don't necessarily match local conditions as much as when you have a national product or a regional product. And again, not to put Varun on the spot, but the work that his center, ICIMOD, does, they're generating these regional land cover products, jointly co-developing them with national governments. And so then when you co-develop a product with governments, et cetera, they say, this is great because we've developed it together and we find it more accurate. So just to say that, long story short, when I started off with SERVIR, land cover was really like the big thing that we used to work on, and have since branched out to other things. I would like to, since I'm in the College of Natural Resources, and 20-something years ago, I was in the College of Forest Resources at the University of Washington. As part of my master's program there, I was, and in case, I guess it didn't come out in the wash, I'm originally from Belize, small country in Central America. And so when I was doing my master's program, it was all thinking about, okay, how do I apply these skills, when I go back home to Belize? And so I got to take a remote sensing class at the University of Washington. And the first thing that I wanted to look for was, where can I find satellite data for like this area that, is important to me? And back pre-2005, the University of Maryland had set up something called the GLCF, and I'm really bad with my slides of like, explaining stuff or whatever, but the GLCF, anybody remembers what the GLCF stands for? Maybe Ross or John, or anybody?
Global land cover.
Look at that, is that on the slide? That's great.
The old guys.
No, the experienced professionals, not the.
Yeah. I know, and sometimes I can't refrain from mentioning the 90s to students. It was important though, elevation, even before that.
I completely agree with you, and I guess that's part of my spiel is to like, for the people who are coming up now, kind of like how things are different now than they used to be, and how understanding how those trends have changed can also inform the work that you folks are gonna do as the up and coming folks. And so just to point out that once upon a time, The only place to get Landsat data was essentially through this system UMD had set up. And does anybody know why this was the only place you could get? And by the way, you can only get like a few images for any part of the world. Anybody know why?
Didn't they used to charge for it or something?
Yes. Any?
We're slow. The server, like, the network or internet was slow, that like you really can't download so much data.
That was also part of it, but the bigger thing was the images weren't free, so the archive started being opened in, I remember it was like April of 2008. There was a press release or an announcement from the US Geological Survey saying that by early 2009 the full Landsat archive would be open. And of course, at that time in 2008, 2009, we only had up to Landsat 7. Landsat 8 didn't get launched until 2013. Landsat 9 was only launched a few years ago in 2021. But if you wanted satellite imagery for your given part of the world, and particularly if you were outside of the US, let's just say it was really hard to get data. And so I just imagine, Center for Geospatial Analytics, if a big part, again, I could be wrong, but if a big part of your analytics is using, Earth observation data and you can't get a hold of it, then it's kind of hard to do work. But besides the internet, say, not being what it is today, there was also a cost to getting that data, because that was the policy of the US government at the time. And so I just have to say hats off to the folks at UMD who had this system, which has since been retired, since there's now, you can get Landsat data from anywhere. And then just to also prove my age, and I'm just about to turn 44 in a few weeks, I like to recycle slides from previous presentations because I find that efficient. And so about 6 years ago, I got to kind of reflect on some of the ways in which technology had changed since SERVIR came on the scene. And it was like 14 years into SERVIR, what are like the 14 big things that have changed? And so it's my list of 14 things, and I'm not gonna torture all of us and kind of walk through those, but the cost of data, the availability of different types of products, the fact that we now have like free access to radar data, high spatial res data. Does anybody in here work with imagery from the company Planet? Awesome.
Yeah, we had a purchase agreement with them for several years.
Awesome.
I guess an institution.
Awesome. No, just like being an older person now, or at least kind of looking at how like the scene has changed and all the stuff that's available now. And anybody heard of Franz Meyer? So Franz Meyer, he's a prolific, he's a professor at University of Alaska Fairbanks, really prolific on Twitter. His Twitter handle is @SAR Evangelist. And so his big thing is, like preaching the gospel of synthetic aperture radar data. And just, his tagline goes that we're living in the golden age of SAR. And then, other people kind of stretch it out as we're living in the golden age of Earth observation, just because, again, like if you were, I guess everybody was alive 10 years ago, but if you were working in Earth observation 10, 15, 20 years ago, like just all the things that we have available to us now, like they weren't around a long time ago. So yeah. I promise you I'll get to the LandTrendr stuff, but I guess one other thing to highlight with SERVIR is, our big thing with SERVIR is, can a tool be developed in a certain part of the world, and then can that be upscaled or replicated to a different part of the world? And one of the reasons why, in SERVIR we work a lot with Earth Engine, is because Earth Engine provides that ability that you could say develop an algorithm or an approach, a workflow for one specific part of the world, and then easily replicate to another part of the world. And that's what we're going to see with the exercise. So Robert Kennedy, great dude, professor at OSU, develops LandTrendr using this is shortly after the Landsat archive becomes available. In 2010, he puts out this paper about this approach to take like this dense time series of Landsat data and how to do something with it for Pacific Northwest. Years later, implemented in Earth Engine, and now you can take something that works in Pacific Northwest and apply it essentially anywhere. And just to say, that's kind of like also our approach with SERVIR. And I should also mention that Robert Kennedy is a SERVIR Applied Science team member. As part of my field, just to highlight, so again, I'm from Belize, and just to mention that, a lot of the work that I find interesting or that I get to work on part of my time has to do with, testing out things in Belize. And there are multiple reasons, not just because I'm from there, but it's a really small country. And so if you test something, you can scale it from, if you figure it out over a small area, then you can see if you can scale it to other places. But in 2010, like a year plus after the archive had been opened, I, got access to, Landsat data from, 1980 through 2010. And then I was able to, with colleagues in the Belize Forest Department and the Ministry of the Environment, come up with a map of, showing change and stuff like that. And so I thought that was pretty awesome. But then, jump forward a few years, leveraging tools like Robert Kennedy's LandTrendr, essentially I can take, not just specific points in time, but I can take kind of like that entire Landsat archive and do something with it. So zooming into a part of Belize just to highlight that, the inputs for something like this, we're talking like almost 7,000 Landsat images that we can then process really quickly and easily in Earth Engine, taking those 7,000 images, chunking them down to 41 mosaics, using a bit of compute, but then be able to essentially extract value from these pixels and kind of see what's going on. And that's what I hope that we'll be able to cover in just a little bit. And so I'm just going to close us off with a little bit more background. Since I think most of the people in the room are grad students in some way, shape, or form, and I know that y'all have to read papers, maybe write them, write stuff up. Kennedy et al. 2010, and then Kennedy et al. 2018. So 2010 is his original LandTrendr paper. And by the way, is anybody planning to go to AGU fall meeting in a few weeks? Robert Kennedy will be there, and I promise you, if you print out a copy of either of his papers, he will sign them for you.
Usually it seems like about half the center's one page.
Awesome.
Lois is very busy.
It's a fun conference to go. I collect signed papers. When I was younger, I used to collect comments. Now, like papers that I find like seminal, I like print them and get the author to like sign them. And so I figure like, one day I'll be able to sell them on eBay, and that's how I'm gonna become rich. Because it's probably not gonna happen too exciting. But Robert Kennedy, again, puts out his paper in 2010, and then after Earth Engine appears on the scene, etc., puts out another paper on that for Earth Engine. And the long and the short of LandTrendr, and I'm just looking at the clock in the back there, and the seconds keep ticking by. The way how LandTrendr works is you have, again, thousands of Landsat scenes over any given spot of the world. And again, free when it's a free and open archive. And LandTrendr will essentially chunk down, reduce those mosaics to, or reduce those data sets to say annual mosaics. And then from those annual mosaics, extract change. Sorry. And yeah. I'd also point out, just because I've been called, I was in a meeting like a month ago or so, I got called a hater by in a fun way from a researcher from a PhD student from Boston University. She called me a hater because I always say like LandTrendr, it's much better than CCDC. And now this is recorded for all time. But in 2014, Jeju and Curtis Woodcock and others from Boston University put out an algorithm called CCDC, which I should also point out is also something you can leverage in Earth Engine. And the big difference, at least I see, between LandTrendr and CCDC is LandTrendr will, take all that data and kind of chunk them down to annual mosaics. But CCDC will take like all the good observations and analyze everything. And so it's really computationally expensive. But some people like computationally expensive. So anyhow, how does LandTrendr work? Yada, yada, yada. I think just because in the interest of time, and sometimes really bad with time management. Again, what it does is let's imagine that every little square here that we're seeing is say NDVI or NDFI, some kind of vegetation index that is extracted from a mosaic, and then the LandTrendr algorithm is able to then fit regressions through the different observations, and then find where, say, if I think a lot of people are familiar with NDVI. Yes. Normalized difference vegetation index. If you see a big drop in your NDVI, why is that? If you have a forested area. Could have been a fire, a disturbance of some sort. Could have been a flood, could have been a fire, could have been a clear cut, etc. And so LandTrendr essentially makes it really easy to find these changes, or yeah, and again, it depends on what you're using. So you can use, LandTrendr also gives you the option of picking if you want to use an index or a specific spectral band, etc. But again, the overall concept is you see this trend. If you have a healthy forest, as it were, it'll be stable for a long period of time, and then when we see a disturbance, then it'll change. Please.
So is this like comparison across individual pixel in your image, or it's just like general study?
Every single pixel, it does regression on. So every single pixel, which is, let's say you have a big country, and you can run LandTrendr over countries, states, national parks, smaller, however you want, depending on how much time you're willing to spend or compute, etc. But it's, at least I just find it really awesome that it's something you can do really easy in Earth Engine. And before Earth Engine, you had to have all that Landsat imagery downloaded and essentially run the stuff on servers. So, any other questions? And I promise we will get to the exercise in just a wee bit. In any event, these slides will be shared with you, and I hope, in the spirit of just that folks will also like check this stuff out on your own afterwards, because it's really cool stuff. Just the general idea that you go from just raw images and essentially complex data to stuff that's useful to us. The LandTrendr paper, and then just a quick example of like for instance, in Belize, and I know the data, well, I'll tell you right now that the data is like really noisy, but the ability of you can take this stuff and create like Earth Engine apps that display it, etc. And let me yada yada yada. And also kind of take that stuff too and look at trends over time. Do I want to go into that? Not really. But just to also say that in terms of additional resources, just because we only have 2 hours and we also still have to cover the vegetation height mapping part, I'd just like to also say that Oregon State University, as part of the eMapper lab that Robert Kennedy runs, they do have some really great documentation on LandTrendr and all the additional details, etc. I'm guessing again that since Rebecca and others, I think, led y'all in an exercise with Earth Engine earlier in the week, that folks already have access to Earth Engine, know how to get it, use it, etc. And just to say too that LandTrendr and the way that we're going to use it is essentially built on or leverages the different Landsat collections of data that are out there. And so, as I mentioned before, we're up to Landsat 9 now, but there's data, LandTrendr essentially uses data from Landsat 9, 8, 7, 5, and 4. It doesn't use data from Landsats 1 through 3. And does anybody know why Landsat 6 is not up there? Random satellite trivia. Landsat 6, anybody? Rebecca looks like she wants to talk.
I think it crashed, but I know it wasn't collecting good data.
Scanline issue?
No, that's 7, but Landsat, so Landsat 6 failed to launch in 1993, and so I wasn't there, but I like to imagine that the rocket goes up and you just see like this great big explosion that destroys a $250 million investment just like that in seconds.
It's a good feeling.
Huh?
That's a good feeling.
But it's the only Landsat, the series that failed to launch. But as John was saying, Landsat 7 does have some issues that occurred afterwards. Alrighty, just to also say in Earth Engine, there's something called the data catalog where you can also find a lot of details about the different sensors, data sets that we're going to use. You can also find information about those collections in Earth Engine itself under the examples tab. I've also put a link there that will link us back to the original script that I'm making a copy of. So Robert Kennedy in his lab was kind enough to provide an example script for part of the Pacific Northwest, and that's what we're gonna look at first. I can share the slides afterwards. But otherwise, for those of you who have computers, if you wouldn't mind going to bit.ly to that specific link that I have there. And then if it doesn't work, please let me know. Please.
I'm getting a thing that says I have to register my project or something.
Yes, so I thought that I'd gotten everybody's cloud projects.
I didn't share the name of the cloud project.
No, that's, so I think the way how it's supposed to work, maybe this is the part where I start to walk around. You might have, if you had given your email to Rebecca, then I put everybody's emails in that cloud project. And then you might have to actually click on a link and accept the cloud project. Otherwise, let me also.
So if you registered for the event, like on gisweek.com, I just logged in and got this prompt that said add repository to your workspace. And it says demo_NCSU 2024. If you didn't get that pop-up, that could have just been me. Just make sure you're in the email that you registered with. If you didn't register, it's pretty quick to make a cloud project. Or is there a way to add?
I've tried this before and it's I mean,
So.
Were you gonna do a pop-up? You got a pop-up? You got a pop-up? You got a pop-up?
The email that you.
Can I look at your-
yeah.
Yeah.
Sure.
You did?
And then.
I can also. I'm sure you did.
You just want me to yell at you across the room.
No, I think you're right, I'll like. Sorry.
There's not a.
It's gonna take a second. I.
So. Yeah. So like I did some coding something, because I have right now.
So just to, I guess just to mention that I did, it's like I have like a bunch of emails from the people who.
Yeah, mine's not in there.
Okay.
Sorry.
So only two. Okay. One more.
It has the shit.
Was for a semester now. Are you excited? I didn't bring my laptop. Oh, I forgot.
Maybe you can join one.
Yeah.
You guys.
Look over.
Oh, wait, also my.
It popped up. Add one more.
So like our.
Another email to Ash.
Master.
This one right there.
Two different.
Eli, HOR. At NCS. With Eli, that's right.
What year? It's not ours. First year.
Did that pop up come up again? Yeah.
Let's see if it's really hard. Yeah.
I don't know. Back. Let's see.
It's my review last year.
So I guess actually.
And I know enough of it. And then I took I swear, and I want to go back because.
But it's actually good.
You had one?
Yeah, a few weeks ago.
Yeah, you're so.
Run the entire thing. Like there's one error.
Yeah. I guess it's gonna be the
Instructor.
I like.
Oh, no.
I like old favorite.
Okay. So under Peter. Demos.
That's really good.
Under Peter.
I haven't tried it.
Thank you.
Yeah.
It's like roads. Okay, yeah, you have your reader on scale.
I'm like, copy and paste out.
I know it, so everyone, once you click it under reader, you should have users /SERVIR BERS /demo NCSU. So if that's showing up in your reader, you're good to go. If that's not, we'll troubleshoot. Apologies for not letting y'all know about the. But yeah, if you're looking, you'll be. Did you get to this? Beautiful. In your first year. I think you're good to go, because it's up there in your. Oh, but it doesn't like that you don't have a cup. Yeah, it's we just actually get.
It does this, right? And then
Yeah, and then it does that. So.
it's actually saying.
It doesn't, it doesn't, oh yeah, try clicking that one.
Yeah, I feel you.
Project is already. Okay.
Well.
Yeah. What is it?
I don't need this.
Oh wait, try clicking back. And then try, click here to go to code.
This is not.
So is this one?
Yeah, no.
Yeah, we're working on this semester.
Go to the register. If you go to the registration and try to get another registration, it doesn't look like this. With all its rates.
Yeah, okay.
Follow along that.
It's just like.
Keeps the feedback here.
Yeah.
Yeah, it's kind of like.
But I'm using like.
Yeah, but I don't have one.
It's tracks.
Like
They're not.
I started a demo last year and all this on that project and I'm never trying to do anything else.
I think like station.
So like create.
Because like
Yeah.
both are like.
Yeah.
Look at it. No, they don't have any tags. So you don't.
Not through
It's here and
like there's a finding, like selection,
Like.
like,
Just like
yeah, you
additional
can do this,
measures.
NC State's email, but this one.
Using other ways to try to estimate.
Cool.
Where they were.
Yeah, you already.
No, you can do the NC State email, should point you have to like.
Oh, okay.
I'll be there. So good talking to you.
Oh, yes. Project name. So my guess is that will not work because NC State that changed the location. School project. So you search file projects in a new window and make one.
So like, yeah, cause I wanna lean back and then.
It's very much like.
File
And that
project.
Thomas Jefferson. Quality out.
Like follow and then like on left hand side.
Oh my god.
Like cloud overview, like word. Oh, you have some jobs.
Yeah. So I think it's like.
Oh, yeah, I did my job. Weird.
I was in my undergrad.
You don't have a cloud project.
You were? What were you on campus?
No idea. I know.
Where were you? Okay, and then you guys kicked off. Okay, yeah.
I remember last year there was a demo.
Yeah.
So who all still doesn't have a cloud project access? So because long story short, you should have maybe in your spam folder an email from me that said, like, you've been added to a cloud project, accept. And otherwise, the workaround, so like I said, at least all the emails that I received, I added those. But the other workaround is that you can also, let me just show you. You can do so I think if you're not, if you have an Earth Engine account that's not your NC State address, you can create your own cloud project. And so I work for UH and we have a similar issue where they've stopped us from creating our own cloud projects under the .edu domain. But I'm able to do that with my Gmail, and that's how I was able to create this cloud project that added folks. And then it looks like there's a question in the chat.
Oh, no, I just said, yeah. The chat's a bit quiet for
Okay.
so we're checking in.
Let me close off some things. So I don't go insane.
I'm in an unrelated, sorry, I'm in an unrelated cloud project. What should I do to try to?
So if you're already in an unrelated cloud project, that's fine. So the long and the short is Google recently changed the way how they authenticate users entering Earth Engine. So if you have whatever cloud project, you should be able to run this stuff. Just what happens is the scripts that we're going to look at, if you don't have cloud project access, we just saw with our colleague up here in the front. If you try to run the stuff without access to a cloud project, it says it won't run because you're not on a cloud project. And so whichever cloud project you have access to, you should be good. So I guess Eli's the only one who has no cloud project access, or are you working out?
I think I'm stuck, yeah.
Okay. I'll travel through.
You sure? And so by chance, Eli, in your email, do you have an email from me about?
I checked and I don't have any emails.
Even in your spam?
Even in the spam.
And then let me I'll just show something for you. I just wanted
I didn't
to.
get anything in my spam.
Gotcha.
I didn't either.
So I got an email from myself last night that said, from Emil Cherrington, it says, join my project on Google Cloud. Like I said, it went to my spam, and then I had to click that little link there to be able to accept it. But Eli, by chance, do you have a Gmail that you could sign up for Earth Engine with?
Like not the NC State account?
Yeah, so like I said, the general issue is with the different .edu emails, different universities have kind of blocked people from creating cloud projects, and so that's the issue.
Okay, so I need to sign up for
Earth Engine with your personal email. And hopefully that fixes it.
Let's go.
This is my first. Oh. And I didn't tell him what personal account.
But so Eli might be the only person in the room right now who's stuck. Also don't like people who are stuck.
Here. But
She'll
she'll try with your personal account.
I'm using my personal.
Like,
Thanks.
it's like, it's in there.
So then I'm gonna register.
Yeah.
No, my.
So that's
One
one.
to my academia still, even though I'm not on an academic.
Yeah.
Just like.
By default.
Organizations.
Oh, and like what you name it.
Okay, so I shouldn't say work around. Yeah.
Just call it nice experience.
Oh, okay.
Then just not this remember others. It's like, okay, well.
This is not going to be. Yes.
Yeah.
Especially for like. So what is?
Yeah, so now we can burn.
Yeah.
Switch then I have to use this email.
Yes.
Oh yeah, it's gonna show you, so like. But I don't know. Yeah. You go to that data set and just like, oh, this is what you did it, right? To get me this image, it's really well documented. Cause I don't know.
Yeah.
A bit easy.
Just here, it's not the
They all kind of. I zero some of the oldest. Like mine.
On felt the amount.
It's like, yeah, it's forward with past the trends. Choose a project. This is.
So you're gonna have to, so if you answer this one, please. Can you
Kind of like, it's being used to write
sign off?
analytics.
By chance you have, or the yes. It look, yeah.
But it's all dependent.
I want to register.
Well, I
have to log out my NC State and log into my first one.
Like what?
I can every now and log out.
But I mean, like,
Yeah.
I would switch.
I still gotta make a
I would definitely.
Or I'll send it to you guys.
They're like certificate.
The only weird one is I just have to, it goes down to the application. And you have to slide 13, I'll send this to you, but yeah, you can make a cloud project and then.
I don't know, I like to keep things in their correct place.
So.
It's just the metric.
Yeah. Okay.
Yeah.
It's a very. You can use your hands. I use my personal, but I will share the slides that have structured around the project. Yeah, it's a little complicated, but it's not. But you can't do it to others, you just have to like on playground. Make hot projects outside of the playground. Which if you're using it that way, you're inside of the building. It's very like.
Yeah. Yeah.
It looks like you had a.
I hear.
We tried to.
One moment. We'll go back to.
Hot project.
To
We don't wanna buy that.
the previous steps. I'm authorized for existing.
Yeah.
What's your job? What's your actually? Yes, the John B. Vogler.
Between programs.
Yes.
Well, yeah, but it was like you have data that like Chris gave us access to, like, is there a way to
Use Google as your.
to basically make things
Alright, yeah. Alright, we're about.
Yeah.
Actually.
Be on our.
Some type of is that.
All right, so I guess we We have gotten the first casualties from Google changing their authentication process, but it looks like hopefully the majority of folks have access to a cloud project. And then the other question for folks is, have you been able to, are you probably under reader, not under owner, able to see something that says users SERVIR BZ demo NCSU 2024? Okay, if that's so, then in the interest of time, we're gonna click on the first one. And the thing I really like about Earth Engine is you can just hit the run button, it just does everything for us. So please, everybody, hit that run button and let's see what happens. And then if anybody gives an error about cloud projects, then I will just die. But is anybody getting like a,
Yes.
okay, who's gotten errors? Nobody? Okay. Anyhow, I guess what I did not, because Vernon could tell you with SERVIR, we give trainings all the time and stuff. This Google changing their authentication stuff is fairly new, and so we've generally not run into this issue previously. Wait just a second. Can we minimize this? Sorry.
I'm so sorry.
Sorry. So if you were able, so. No worries, no worries. So I said, for most of you, this, for everybody, you'll see the repository under readers, right? And of course, I have it under owner because I'm the one who created it. And you'll see the 3 scripts that I wanted us to have a look at. So we're obviously gonna adjust on time just a wee bit. But just to say that this script is just a copy of another one, which I could give you the link for that we could have a look at, or maybe not. But Robert Kennedy and his team have this much larger repository that has different example scripts. What is this showing us? Long and the short is, if you were to zoom out, this is just some part of the Pacific Northwest. I think probably someplace in Oregon or Washington State, where he's we're able to run LandTrendr for. The specifics thereof are specified more down in the app. I would encourage us, even though we lost a little bit of time, but I would encourage you to check out lines 22 down to say line 50. And if you're able to open that and check it out, any guesses as to what's there? It's all gibberish. No, I was just curious if, huh?
Maybe I'm competing 1 year in day.
Uh-huh. Tell us more, please. You're on the right track, you're correct.
They started like June 20, and then they ended by September. Yeah, so that's what I'm saying.
Yeah.
And then you have some kind of threshold to determine if this has changed or not.
Until I was 200% correct.
Oh,
So
no.
just to say that, and again, for those who are, maybe a little bit newer to Earth Engine or whatever, the awesome thing is, again, we are taking all of the Landsat images between the year 2000 and 2020, and then we are filtering them down to, I guess, what are the better, sort of like the dry season, as it were, the part of the time of year where it's not so cloudy, so it's sometime during the summer. As Titulai pointed out before, on line 20. So the years that we're running the stuff on are dictated in lines 23 and 24, but also in line 46. And the season that we're chunking it down to is 25 and 26. But then also, this part of the script in line 28 has a function where it says, use these pre-existing masks that Landsat has to essentially remove pixels that likely have cloud, shadow, snow, and water. And yeah, and hopefully, and I know that we've been hanging out for a whole hour now. But if you remember one of the earlier slides that I was showing, what LandTrendr is doing is taking, again, multiple years of stuff, extracting out areas that have changed, and then coloring them in these different pixels that we're seeing there. And although I know that a few people in here have said that you don't like using Q or you don't like using ARC because you guys like using R. In ArcGIS or QGIS, you're probably really familiar with the I button. What does the I button do in ArcGIS? Or Q?
Q, it'll kind of, if you click on a pixel, it'll tell you what that value is supposed to represent.
It gives you the information. And so in Google Earth Engine, we have something called the inspector. And so I would like for y'all to click over on inspector and then just click on a pixel and interrogate it. And you can click anywhere, you know, it's not a wrong answer. You're not gonna, you know, get something wrong or whatever. What are you seeing when you click on these different colored pixels?
Year of detection.
Year detection, what else?
Change.
You see something called mag? What do you think magnitude? Sorry. What does mag stand for? I just gave it away.
Magnitude of change.
It's a magnitude of change. And so, again, I'm sorry that Google had to mess up our plans. Just kidding, especially for the recording. But we're taking 21, we're taking, you know, 20 years of data, we're chunking them down to 21 mosaics, and even though it's 20 years, it's 21 mosaics because inclusive of the starting year 2000. And we've just pulled out, again, areas that likely had timber harvest or some other types of changes. And again, let's not look at the code, but we can click around, see something happening there. I'm also guessing. It'll take a little while for it to recalculate. So also the other thing with Earth Engine, when we click like run in the case of this script, we're doing everything on the fly. And so it's recalculating everything on the fly right now. It'll take a little while.
There was a question in the chat that said, what is the mag value supposed to represent?
Yes.
Like 600 out of 1,000 or something.
Thank you, Laura. I believe that if I'm not mistaken, I think I believe it is. Let me just look at this again. So if we go to like the original LandTrendr script, it is indeed, or if I feel bad making mistakes, but yeah, I believe it is out of 1,000. And so what it's saying is, you know, in this case, if the NBR, which is the burn ratio, as it were, drops by 300 over 1,000, in other words, by 30%, then identify that as a real change. And so this is also something that, you know, you can say, all right, you know what, 30% it's not sensitive enough for the change I want to look at. Like, give me a 20% change, or give me a 15% or a 10%, etc. Of course, if we change that value to be, you know, lower, then we're going to get more change than we might want to see. This is the area that I wanted to see, and Titulayo, please go ahead.
So does it just show 1 year of change? So assuming there is a change in 2015, there's another change in 2019. So does it, because clicking on each of the picture,
Yeah.
it's just showing just 1 year. So can you also see like show us like other years if they are like 1 year?
The short answer to your question is yes, it is possible. The way how this works on line 45, we can tweak what it has there. And so this is taking like over that 20 years of change. When did the biggest change occur? but you could also change this to, from greatest, you could change it to first, or you could change it to last. The way how the script is set up, it'll only show you one of the possible changes that occurred. The first change that happened, the biggest change that happened, the most recent change, etc. But you can also tweak that parameter. I don't know, and I don't work in the Pacific Northwest, so I don't like know the different changes I'm seeing. But if I had to guess on it, if you notice the parcels, or to me it look like parcels, the different polygons or what have you that are being generated, say over on this side here, you notice that the shapes are fairly regular, whereas like over here they're more irregular. And I'm dealing with spatial people, spatial geeks, and so maybe y'all have better terms for these. But if I had to guess, this looks like it could have been some kind of like a disturbance, like maybe it was. I think it looks like a fire, like the boundaries of a fire, and this stuff looks like harvests. But again, I don't work on. I don't. I'm not familiar with this area, but what I did want to highlight was. And in my slides, which you're gonna get later, but I could also throw that up there. There's this is just a modification of a script that came out of the eMapper Labs public repository. And they have a bunch of examples there. And so this one was from the greatest disturbance mapping, but they also have another one for greatest growth. And so in this case, we're using LandTrendr to look at negative changes or things where the NBR has dropped. But you could also flip the script, literally, no pun intended. You could flip this and also use LandTrendr to find areas where you've had regrowth. And so I don't know what y'all work on at the CGA or whatever, but I know that Titilai, for instance, works on ghost forests. And so you could use LandTrendr to find where you had a healthy forest and then suddenly NDVI or some other index has dropped, which indicates that you've gone from healthy vegetation to unhealthy. And so just to say that there's like all sorts of different applications for it, but the reason why my mind is just blown by LandTrendr is that you're taking essentially thousands of Landsat scenes, reducing them to these manageable annual mosaics, and then extracting out information that you can use in terms of change.
Yeah, so it seems like LandTrendr is just a general algorithm to say this pixel changed, maybe down in value, or up in value. But like in this example, all change is being represented kind of equally on the map.
Yes.
Does LandTrendr also like classify types of change, or just shows you this is changing and then leaves it up to the user to identify that this is a fire or a burn or streams?
No, that's an awesome question, and the way how this script is set up, it's just giving you everything. And if you noticed, it didn't, like when I was zoomed a little bit further west, it even picked up change over like a body of water or whatever. And so it's just basically finding, and it's possible maybe that body of water wasn't there before or whatever, but it's just picking up all the change, and it's kind of up to you to then, you can say mask out the changes that you are not interested or kind of keep the stuff you are. So the other example that we're gonna look at, and then I'm doing badly on time. The other example that we have is I have taken this LandTrendr data and I've tweaked it for Belize. Just because it's a context I'm much more familiar with. So again, the thing I really like about Earth Engine is, at least when we get through the cloud issues, you don't have to install anything. I don't have to worry that, oh, you don't have, whatever Python library installed. And so if, just kind of following up on that, and by the way, Rebecca, did you have a question?
Yeah, I have a quick question.
Please.
And then I do unfortunately have to run.
No.
I'm curious, I saw that you, in the first script, you masked out water, clouds and water. But then I'm also curious, since there's a lot of flooding folks in here and me among them, can you use like the modified normalized difference water index to detect change? Cool.
Yeah, yeah. I know I was nodding, but well, let me verbalize. So you as the operator can also choose the things that you don't want to mask out, and so I think that previous script that we were looking at is more say optimized or whatever for looking at changes in forest areas. And so it's when it says mask cloud, water, etc., snow, it's because you also want to basically it's saying don't give me pixels that likely have cloud cover that might interfere with the index that I'm looking at, but you could say take those out in terms of what you're masking, but you could also change the index that you're using to look at change. So yes, if you had the NDWI in there, you could also kind of look at those trends in NDWI. And I guess the other thing that because of the interest of time, that I kind of glossed over, the output that it's giving you will essentially be a TIFF. So you saw when we clicked on these areas, it gave you a year of detection, right? When the change was detected, it gave you a magnitude change. It also gives you a stack, as it were, essentially a geotiff that has multiple attributes that you can also kind of play around with to see other things that are happening. So it's not, as it were, just a map of change, but it's giving you this additional information. And I know that people in different parts of the world have been using things like the magnitude to understand certain changes, because some in certain types of ecosystems, say we have, I guess you probably don't have mangroves in North Carolina, right? But in other parts of the world where mangrove ecosystems are important, the changes in mangrove ecosystems are likely to be subtler than you would find with, like, say, clear cutting of forests in the Pacific Northwest, etc. So you have additional stuff that you can play around with. And I'm sorry that Rebecca has to leave, but she got stuff to do. Everyone, please, and also Eli.
So I was like wondering how LandTrendr is different than MuntCondel or modified MuntCondel, right? Because we use MuntCondel a lot when dealing with remote sensing data, and it also gives you similar kind of parameters like increasing, decreasing trend, and inflection point, the year of change, and those kind of stuff.
Not familiar with that approach, to be honest. I'd be interested to find out more.
LandTrendr is based on linear regression based approach, or it's like non-linear?
I believe it is linear regressions that it's doing. And then also ultimately for say any 2 pixels right next to each other, you could get like really different forms of regressions, but LandTrendr also kind of simplifies them out to say similar patterns or whatever. So part of the model. So let me just pop this up in a different script. Okay, so so a big part of it as well. So like the previous script that we're looking at, line 30. The spike, so the number of segments that we're using, the thresholds, etc., are also kind of tweaking the parameters for the regression that we're going to do. And so we could have essentially I want a fitted line that has 20 segments or something, right? Or we want a more simplified one, and then also it uses p-values and other things that we can again tweak. So there's multiple ways to fix the fitting of the regression. Best model proportion, if I'm not mistaken, and by the way, all this stuff, there's a LandTrendr page that has much more detail on it, but I believe too for any of the regressions it's doing, saying, like in this case, only display a result if the fit of that is an R squared of 0.75 or above. On the server side, we've played, it's like, okay, you know what, 0.75 too high, let's go at 0.7, right? And so there are different things that you can mess around with. So like the p-value, we don't change that one, but we've definitely done things where we've changed the R squared. the segments doesn't seem to, really matter, but different things. Also, let's say, if you're, a lot of you folks, I'm assuming some of your work is focused here in North Carolina. The seasons that you're looking at might be slightly different, so also kind of requires your own knowledge of the situation. So like, for instance, when we've run LandTrendr for Amazonia or Central America, the dry season there is much different than it is in the Pacific Northwest. This example that we've done right now is set for 2000 to 2020, but you can also run this stuff all the way back to 1984. It takes longer to do that longer run, but there are all these different things that you can do to tweak that. And I just, I just find it really cool that, like I said, this is one of these things that's easily accessible to anybody in Earth Engine, that any people can kind of get value out of if you focus on land. Please, question.
Yeah, so with the first example, I was wondering with the magnitude of change, I know it's the greatest, but then with the year of detection, is the magnitude of change, is it detecting it from the year 2000? And so then the year of detection is that year. So like if it says 2011, is it between 2000 and 2011? Those two was the greatest change, or is it from like the year before 2011? Like what's the baseline?
It generally, so again, it's like, it's making this stack of annual mosaics or whatever, and so means between 2010 and 2011, some change occurred. We saw it in 2011, and that was the biggest change that we could spot. Of course, if we changed it from greatest to first or last, then that date would shift in time. That's my understanding of it. Please, Eli.
Yeah, so you covered this a little bit, but I was curious about the parameters and how much you calibrate the parameters for like the specific location and specific times that you're looking at. Like how much do you think those need to change? Like how much time are you spending doing that when you're trying to run this model? Or how much of it is just like, these are like global bests, stick it in, see what happens? Is it kind of like, very situationally dependent, or is it like normally, we want to play with this one if we're not getting the results that we're hoping for?
The latter. So on the SERVIR side, we had an activity that Robert Kennedy and others were involved with, where we were looking at the outputs from LandTrendr, stuff from CCDC. Another SERVIR PI at University of Richmond, she made her own change algorithm called MTDD. Don't ask me what that stands for. Her name is Stephanie Spera. But we were trying to understand region by region, and also using land cover maps for these specific regions, like land cover maps from the Hindu Kush Himalaya region and the ICIMOD produced, to see, okay, ICIMOD has these change maps. Can we essentially tweak the LandTrendr parameters to match the changes that it's picking up? So our understanding was it really is regionally dependent. But also, again, we figure like you folks, each of y'all are doing, individual work, not to just because the things I've memorized, to Delayo and her Ghost Force work in the, Carolinas coast or whatever. She might already, from looking at Sentinel data and Landsat data, seen specific, patterns that are changed. And so she might say, run LandTrendr with the default parameters or whatever, and say, you know what, it's overestimating or it's not picking up enough, and then figuring out how to then tweak that, whether it's based on, generally in this, line 30 down, the different parameters for the regressions, or some of the other things. No? But of course, it's I guess all the time in the world. The other thing, so LandTrendr, was set up to run on Landsat, but the code that's there can also be used on MODIS data. So like, for instance, we have daily MODIS data going back to late February 2000. You could run LandTrendr using MODIS data. It'll still, the way how it works, it'll still chunk them down to annual mosaics. So it's not like CCDC, so it's not going to use every single pixel. Or you can use LandTrendr with Sentinel data. You can use LandTrendr with the planet mosaic data that's available through Earth Engine. So it's essentially a framework that could be applied on other sensors as well. And because you're using say Sentinel-2 data is finer scale resolution, it's, there's 10-meter data, et cetera, you might get better results than you would from Landsat. Yeah. Other questions? Mine's a blow, I'm not just kidding. Or at least, so this stuff was released in Earth Engine in 2018. I only found out about it through Twitter, like on Twitter, like there was this Earth Engine user summit happening in Dublin that I didn't get to go to. But Kel, one of my coworkers, did go to. And like people were posting about stuff. It's like, hey, hot off the press, this just came out. Like check it. And it's just like you can take this stuff, you can tweak your AOI, you can like run it anywhere in the world. Like you're creating data out of nothing. Isn't that what you guys want to do with CGA? Like create new data? Huh? All right, like for me, that's always been like one of the pulls of like working in geospatial and specifically in the Earth observation side of geospatial is like, I used to work for the government of Belize and, almost 20 years ago, it's like we were dealing with a lot of stale and static data, like we're dealing with like soil data, elevation data, things that we didn't see as changing very frequently. It's like, and then boom, now you have like all the satellite imagery and you have this tool that like a Landsat image is ingested into the archive, right? Like Landsat data comes out every 8 days as it were. Like you could be running LandTrendr like all the time to pick up these new changes, you know what I mean? And so like you folks could be the ones like, hey, we got like the hottest, the latest and the greatest, no? At least that's the stuff I geek out on and I find really cool. So yeah. Yep, I'm doing badly with time. The other script that was there, if you click on it, I think the only thing that I wanted to highlight there was just to show you. So again, if you have just started down your Earth Engine journey, Earth Engine provides you with ways to. So I've also made a viewer. So this script is not a viewer per se, but I also have a standalone viewer that's based on this that runs on Earth Engine, which I could access, but not gonna bother right now. But let me just kind of walk you through some of the things that the script does, and it's all based on LandTrendr. I've taken, so LandTrendr inputs these inputs like again 7,000 images, spits out 41 mosaics if I parameterize it like that. And what I'm able to do then is export those mosaics, save them. And in this viewer, the reason why this stuff, for instance, runs quicker than some of the other stuff is because I've saved out everything, which is what you can do. And I can look, year by year. One thing that I could do is probably gonna give me some timeout error. Nice. But the long and the short is, the same mosaics that LandTrendr is essentially generating as intermediate inputs for mapping that change. We can save them out to then see, what's happened. And then I can also make, say, additional value-added products off of those. And so I don't know how much folks in the room love or don't love forests. I love forests. I got trees in them. Forests are fairly, we're talking like just, like you're talking about like land cover on a whole, land cover can be, kind of tricky to map and whatnot. But yes, Laura online loves forests too. You're awesome, Laura. Land cover can be kind of tricky to map, but like forest non-forest is not that challenging. And so I'm using a kind of thresholding approach using spectral mixture analysis. Spectral mixture analysis. Anybody in here done spectral mixture modeling? John's nodding, so John's gonna explain it right now. Just kidding.
I did VIS, vegetation, impervious surface, soil.
Tell us more. Tell us more.
Oh, it's a long time ago. I'll go to the spot.
All right. Like, who in here had to take chemistry? Sure, everybody had to take a chemistry class. Did anybody ever do spectroscopy?
I did. Yes, I assessed heavy metals with, it was water samples. The water, so we did a spectral photometry. And observes, like atomic level. Something. It was a long time ago in also.
At the VIS, I remember something.
Please.
It basically come up with on per pixel basis, a probability of what portion of that pixel is soil, what portion is vegetation, what portion is impervious surface. Per pixel for your entire image. So,
And so, just like what John was saying, something that, like one approach that we've tested out for parts of Central America, not just Belize, is on a per pixel basis, extracting out how much green vegetation, how much non-photosynthetic vegetation, and how much bare substrate we can see in a Landsat pixel. And that's the second thing. So again, y'all have access to the script, and so you can turn on and off the layers if you want and kind of see. But essentially, from the raw Landsat image, you can model what these different proportions are, and then based on that, those raw proportions, we can extract off and say, all right, if an area has X% of green vegetation, then let's call it a forest. If it doesn't, let's call it non-forest, or let's call it water or whatever. And so we've taken, LandTrendr, generate these inputs, come up with forest cover, but then also we can take those same land cover change maps. By the way, with ArcGIS, you can do cool stuff like throw on legends and whatnot to generate independent apps that regular people who don't have Earth Engine accounts can use, etc. And so then we can like zoom into areas. Hopefully, it's not going to throw some kind of tile error like it did just now, but we can, we see that the area's changed and why, and then drill down the years when those changed, etc. So just to say, with LandTrendr, and I'm biased because I think LandTrendr is like the best thing since sliced bread. But you can do some really cool stuff with it. That's my story, and I'm sticking to it. Please.
So just a small question.
Please.
So LandTrendr, if I understand it, relies on like annual mosaics of.
LandTrendr will take all the stuff and generate the animal mosaics.
So what happens if you just gave it like not every image from within a year? It would also.
No. You specify the date range, and you can say, okay, let's use a full year. It'll still take all of that, and it'll make one image per year.
So, but like fundamentally, it relies on just like annual change. You can't do like some.
If you wanted to look at sub-annual change like everything, then you would use an algorithm like CCDC. But LandTrendr, as you could see earlier with that Pacific Northwest example, you click it, you run it, and boom, like within minutes you have a result. CCDC, you click it, you run it, and within hours you have your result because it's using a lot of compute.
Maybe there's like some benefits, but
200%, yeah. And so for people who are doing more like early warning or early detection of changes or whatever, they might want to use every single image. So that's stuff that folks are working on. Great question. Other questions before we get into the break that we're not having and the height stuff? Please.
So
no breaks for anybody.
the algorithm
Google's
is
fault.
like
Just kidding.
running, by like pixels. So I guess, is it like relying on like Tobler's law or anything to say like two of these pixels that are like close by each other are like related or anything?
Not really, but it does have. Let's go back to the earlier example. 1 second. There is a minimum mapping unit, so it essentially will filter, it'll filter based on, say, groupings of pixels. And so if you find, in this case, where it's using, 11 pixels that are next to each other, and why 11? Why 11? Come on. Person with the correct answer gets a free NASA sticker. Brought some, by the way. Come on, why 11? All right, what's the area of a Landsat pixel?
It should consider like 11 nearby pixels.
Yes, but why 11? Or what's the area of a Landsat pixel?
Okay, so
900 square.
Huh?
900 square meter.
Well, a Landsat pixel is 30 by 30, so it's 0.09 hectares. So by doing 11, you're getting roughly 1 hectare's worth of change. And since all of y'all go out and cut forests and stuff, because we're all foresters in here, they for this example, he picked 11 because he wanted a hectare. But Varun, you were gonna say, please.
no, I think it's the same thing.
Everybody will get stickers. How about that? It's Friday.
It is Friday.
I don't know you. I don't know you folks. So it might not seem it, but I do get nervous when I give this stuff. Usually when we give SERVIR trainings, we like do team sports. So I'll teach something and then somebody else will back me up or blah, 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 like it's not just me. So, yeah, so I have to laugh. Because in a great movie, I'm not not endorsing any specific software, even though I've made all kind of jokes about R. I really like R, true story. I'm not endorsing software, I'm not endorsing data, I'm not endorsing, platforms, not endorsing movies. But anybody seen the movie Training Day? I say what? You never seen Training Day?
I don't know. I can't recall.
That's Denzel Washington.
Denzel Washington, Ethan Hawke,
They're cops or something.
yes, So there's a point in the movie where Ethan Hawke says, you only have so many laughs and cries in life, And so I've always kind of came out in 2001. I've always kind of taken that as like this philosophy of, it's like, it's better to at least laugh than, when the stuff stopped working, I just break down and cry and whatnot and capture it on video and you guys share it around on your YouTube. And it's like, hey, you remember the time when that, dude from SERVIR was crying because the stuff didn't work? That happened, but in an alternate universe that, yeah.
We're a friendly bunch, so.
The Brady Bunch, the Brady Bunch, that's how we came, the Brady Bunch. Okie dokie. LandTrendr, use it, it's your friend. Go to AGU, meet Robert Kennedy, print his paper out, he will sign it, he's a really nice guy. He'd be super embarrassed that, I'm telling you that he's signing my LandTrendr paper, so, that all said. Cause I like to laugh. Okie dokie. Folks in the room or folks online, I'm sorry, but I can't see the chat. Any questions before we go into the final 20-something minute stretch?
I have a question. So I was comparing my.
Make it an easy question though.
Yeah, it's very easy, it's very easy.
One I can answer.
Because you were describing the collection parameters. Since I work in Brazil, the area of my study I've had selected for 3 months, July, August, September. So when you add those other detail parameters, it's because you're considering variation between the dry seasons. I was curious because I was approaching for months and you approach from this other detail parameters, what I think is great. I want to see if what I'm doing is wrong.
No. I think it goes back to gentleman in the corner who sorry, I didn't remember your name, about his names. Huh? Tom. So where Tom was saying about, so LandTrendr's focusing on this annual approach, but CCDC even has kind of a harmonic function built in. So because also the fact that, so if you're looking at multiple months, maybe you get some rain or different changes in vegetation moisture between them. And so it sounds like if you're looking at changes within a year, then CCDC might be a better approach for you to use. And CCDC is also built where you can also tweak which vegetation index you want to use, the magnitudes of change that you want to use. I was at a workshop like a year ago where I told one of the people who was from Boston University that, oh, CCDC is just like a copy of LandTrendr, but it just works annually. It works on every image instead of annually, and they're like, no, that's wrong. Yeah, I'm glad all these jokes are gonna get in the video that's gonna get published online, and hopefully I'm not gonna. But yeah, back to your, I think you could use CCDC to kind of look at that, because if you're only using LandTrendr, then you definitely, like, if you want to look at like month-to-month changes, then it wouldn't necessarily see that, or at least, let's say you had a change in July, and you had a change a few weeks later in August, it'll just show you all of that as it happened in year X instead of it happened, a specific time period.
Thank you.
That's my thoughts. And CCDC also has great documentation online. Yeah. Any other questions? Oh, it's Friday.
Can LandTrendr be used outside of GEDI?
I use LandTrendr to make coffee in the morning. Yes. So LandTrendr was originally set up as IDL code. Anybody in here does anything with IDL? Okay, but there's also I believe that there's an ArcGIS version of LandTrendr that uses the Landsat data in their living atlas. I couldn't tell you more because I'm a big Arc fan, but this is where I prefer Earth Engine for some things. It's kind of like you're gonna eat I don't know, you're eating a meal and it has some protein, it has some veggies. Maybe you have a fork, maybe you have a knife also, right? So I like to look at, like G, you do certain things with G, other things you might use Q or even R as our colleagues over there. Other questions? Far behind, but anyway. Questions? All clear, no. Anyway. I also know, it's like, sometimes it's a lot of stuff to like cram down people's brains in like an hour and change. If not, then let's take an imaginary break. That's not gonna happen. And so then, wow, that break went by really quickly. Vegetation height. So, I don't know why I threw this slide in. Maybe we'll skip it. Just kind of curious. Do you guys hear the words Geo AI every day of your lives, at least the 5 days a week that you're here? No?
There's a class called GEOAI, I think.
Awesome. Skip this slide. There was a reason it was in here, but I can't remember the reason. So on the SERVIR side, we get to pull on a lot of really cool science being done by other parts of NASA. And so John Armstrong and Laura Duncanson, they both work for UMD, University of Maryland, and they support work at NASA Goddard. They're both parts of what's called the GEDI science team. I should have thrown in a slide showing you what GEDI looks like. I've never seen it myself because I've never flown up to the International Space Station. Anybody in here has gone to the space station? Got stuck there for. So when they give these slides, which I'm borrowing just a few slides of theirs, they have this cool thing. It's like, look, GEDI is like shaped like it's the size of a small washing machine, like one of the small ones that fits in like an apartment in Europe, like I used to live in. LiDAR, I'm sure y'all have heard about LiDAR, so I'm gonna skip that. But just to show, but just to highlight the idea that for people who are watching this video in the future, the reason why we're skipping this stuff is because we ran out of time, because Emil planned badly. Just talking to the people in the future, maybe the people online too. TV land. Just the general idea that, you know, the LiDAR data will essentially pick up on, you know, the different areas in a tree canopy where you have lots of biomass, et cetera, et cetera. We can use it to estimate, you know, heights and ground, et cetera. And just to say also that in terms of different applications of the LiDAR data, the GEDI folks in particular have been using this type of data to look at biomass. But if the term biomass isn't your thing, maybe you folks are interested in going commercial, and maybe you're looking at, you know, like you work for a company like Warehouse and you're looking at timber harvesting or whatever. LiDAR data can also be used for looking at, you know, densities of timber for commercial purposes, because this wood came from somewhere, right? So yeah, just to say there are different things that can be done. And also, folks, including from the GEDI science team and other places that have used vegetation height data in places in the world like Gabon to look at how, you know, ecosystems are, different ecosystems have different, say, height profiles, et cetera. And some of the older LiDAR data from one of the first spaceborne LiDAR missions, probably the first. There was a satellite up there in the early 2000s called ISAT. It had this cool sensor on it called GLASS, Global Laser Altimetry System. One of y'all is going to give me $1 million for getting that right. We're on Who Wants to Be a Millionaire? Just kidding. And so GEDI, which is a system on the space station and just got turned on or reactivated this year after being turned off for about a year. GEDI is essentially a successor to ISAT GLASS, and NASA also has a full satellite called ISAT-2 that has a different sensor called DTL. So that's all we're going to hear about LiDAR for right now, because we're going to go look at that Earth Engine script in just a wee bit. Sorry, people in the future who are getting shortchanged. But if you want to learn more, you don't have to trust me. You can read the actual algorithm theoretical basis documents, or the ATBDs. And so the GEDI science team has put out some really cool algorithm theoretical basis documents, or ATBDs. You can find them on, just have to Google GEDI and you can find them. And they explain the different products that they've extracted from these, you know, samples that the GEDI instrument is capturing. Before I hop, okay. Any questions? We're gonna go really quick through this stuff, because it's not bad.
So I have a question, the CCPC I can find here too, or it's in a different center?
Not in this this repository, but I can afterwards, if I can get your email, I can definitely set you up with more resources, or you could also Google CCDC plus GEE. You're gonna find yes, some awesome repos on that. Any questions on GEDI? No. Anybody guess why they called it GEDI?
Like Star Wars?
Ding, 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 ding. On Twitter, their handle is @Jedi_Knights. If y'all are on Twitter, please follow the Jedi Knights. Also follow me. I'm on Twitter too. I need them followers. Okay. I love saying, in the interest of time. I saw this lady over there. She's been checking out stuff from Ujaval from Spatial Thoughts. You have access to one of his repos. So Ujaval Gandhi used to work for Google, and then he set up his own as a company called Spatial Thoughts, and his focus is on capacity building in all things geospatial. And earlier this year, I saw Varun nodding. earlier this year, Ujaval put out this really cool article post about how you could upscale GEDI data using commonly found data. Commonly found, imagery, et cetera, et cetera. Some of the things which are listed there. But I saw Ujaval a few weeks ago in Dublin at the Geographic conference, and he was commenting that even though you can do some really awesome stuff with Earth Engine prior to this didn't have any materials about kind of upscaling data. And so data fusion, upscaling, gonna throw out all kind of terms that I don't know, maybe you hear all the time, or maybe you don't. Just the general idea of like, so the GEDI, just because I'm a really bad teacher, what I didn't mention is, so GEDI is only like sampling, like spitting out these taking these limited samples, and so it's not covering, it's not getting like wall-to-wall LiDAR estimates like you might get from an ALS instrument fitted to an aircraft, or even a TLS that maybe gives you like a fairly big-ish small area. I know that's an oxymoron. But you take your GEDI data and you can essentially, match it with, say, Sentinel data, and from that you can then upscale it and get this. And so, actually, look at that. It's actually showing that. So you might have Sentinel data covering a whole country or a big area, like a national park, or a ghost forest in eastern North Carolina, like Titulai is focused on. You might have some GEDI data over that area, but the GEDI data is like really small. And you say, let me take this and combine it with these little samples, and boom, let me, through what seems like magic, or geospatial analytics, to quote the folks from the CGA, leveraging geospatial analytics, let's upscale and estimate height, or biomass, or other things that GEDI is coming out with. So yeah, just give you an example, and I'm sorry, but all my examples apparently are from Belize. The little red areas that are really hard to see are from the GEDI canopy height estimations. And actually, the GEDI data gives you from RH0 all the way up to RH100, and so it's just these different vertical estimates for where the signal is hitting. And we can take the GEDI height data, which again is not wall to wall. We can take Sentinel reflectance data, and we can essentially combine them, fuse them to then do a big regression and estimate the height over a whole country. And depending on the different variables we throw in there, you get like a really good fit, really good R-squared. We can do the same kind of thing with biomass. And so the GEDI folks also apply algorithmic equations, take that height to estimate biomass at the plot level. And you can also, again, take these little samples of estimates of biomass, combine them with other things, and then estimate biomass for a whole country, get a decent fit. Don't look at that up there. Any questions? Because we're gonna do this stuff right now. No? Please.
I guess this is biomass, but it's like when it's height, like how large is the error in a scale of like meter or feet?
We're gonna check that out right now with the script.
Yeah, I wanted to add something similar about the above ground biomass. I was thinking like, how did they fit in regression for the height to get the above ground biomass from those point cloud, and just like how accurate it is to the actual tree height.
Yeah. So that's a good question, or good questions rather. I'm pretty sure that Laura Duncan and the GEDI science team are going to be at AGU and can answer your questions, but no. Part of the work that they're doing with GEDI, they have access to ALS and TLS data, so they have like samples from different points in the world, like I believe also French Guyana, where I did my some of my PhD work. They have ALS, and so they are essentially calibrating, I believe, the satellite estimates off of field plot measurements that include, field measurements of height, TLS and ALS measurements of height, And then because they have, you know, plots, they also have DBHs off of which they're estimating biomass. That's as much as I'm able to answer, since I haven't gotten any more coffee since I came into the room. Maybe after I get some coffee, bright ideas might come to me, but with the water I'm drinking, it's not happening right now. Okay, and then just to, you know, just to also show, you can do it on a whole country, you could also like zoom in and like, you know, this is like, look, zoom in, it's great. I don't know, y'all like maps, right? Of course, no. You ever like go to like talks or whatever, particularly from my little tangent? You ever go to talks, particularly from like GIS people? Hold on. Somebody in the chat said, Laura says she likes maps. Awesome. Laura, why aren't you here? So on Twitter, some months back, I still call it Twitter, by the way. Anybody on Blue Sky? Follow me on Blue Sky too. Same handle. But on Twitter, some months back, I retweeted somebody. I said, this person won the internet today because they said, like, they were gonna say, you know what? I'm gonna go to a conference. I'm gonna put some slides. I'm gonna say, and I like maps, and you know, I work with maps, and that's why. It's like, yeah, I can't remember the full joke, but it was just like this general idea that you go to these, you know, conferences. Sometimes they're not so interesting, but it's like, particularly us who like work with maps all the time, or work with spatial data rather, and then yet we don't put maps on our slides. And it's just, you know, like, you know, the stuff you say might not be so interesting and whatnot, but then people don't even know because they're staring at a map. So that they see the map and they're like, yeah, he's 200% correct. I see y'all staring, like, you're looking at the image over here, you're looking at over here, and you're like, yeah, this looks believable. Of course, you're not from Belize, but anyhow, we have a whole like 9 minutes left. Just to also say really quickly that, by the way, just like the Landsat data, you can get like, you know, full you know, descriptions of this data in the Earth Engine catalog. And again, the data goes from RH0 all the way up to RH100, which is pretty awesome. That's the height data, which is GEDI L2A. There's L4A, which is above ground biomass. The D is for density. And yeah, and so same, and we're gonna get to the exercise, and I'm gonna give a shout out to Kushen Wu, who was here last year, for some of his stuff. It's the third and final script in the repository. And then the best part would be if one of you tells me the asset's not shared and it's broken, and then when you tell me that, I just like walk out and I walk all the way home or something. Is anybody getting an error?
Yes,
What did I not share?
the third one, CHM fab.
Awesome. I'm pretty sure I shared it this morning, but you know. Let's test if I really am gonna walk out. I guess not. Look at that. Okay. You guys hit, you like refresh your, you know, you press the link and you tell me if it's shared now.
Looks like it.
Awesome. You hit that run button. You get a great result. We're all happy. We all go home. It's Friday, you take the afternoon off. You don't come to the talk this afternoon. You don't see some of the same slides from this morning. I was like, what if I just like do this demo just like that? I was like, no, I need to get slides. It's like, where do I get my slides from? It's like, oh, I made slides for this talk in the afternoon. I'm just gonna use some of those same slides in this talk in the morning.
Can I type my email address there to get the, yeah, because I use my personal account.
All right, let's add you. All right, what's your, please. You as a predator, it's safe, and then you are hopefully good. Okie dokie, by the way. The LandTrendr stuff, you could run it anywhere, you're doing research in. Just because you guys, want to be dangerous, I'm not doing research in North Carolina, I'm doing research in Alaska. Hey, go ahead, run LandTrendr in Alaska, it'll work. This height stuff, this is just examples, and so just so Ujaval's original scripts, he actually has them in 3 parts, where he preps the input data, he runs them, and then he does tuning, hybrid parameter tuning. But I knew that I did not have a whole hour with y'all, so I wasn't gonna prep the input data with y'all, because why? And I said, you know what? I can combine the hyperparameter tuning thing in the actual script. And so we're just gonna do something in a wee bit. Y'all are kind of getting, or is, okay, so I think folks have gotten something that looks like that. Yes, if it works. So, all right. Just to check if anybody's sleeping, because even though everybody's eyes are open, I know that some people are really skilled with sleeping with their eyes open. What's the RMSE telling me? How about what's it telling me? It's root mean square error of what?
6 meters.
It's, it's the base, but again, it's off of the height, right? So anybody want to guess what the observed heights are? What's it's so what's it treating as observed? It's what's GEDI's observing for the RH98, and then putting John on the spot again. Why did we use RH98 and not like RH100? Anybody in here play with LiDAR data every now and again? No, not really. So I have a forestry degree, but my wife always tells me, name that tree, and it's like, you got me. So I like to play a forester on TV sometimes. So RH100, let's say you had like LiDAR data from like an ALS or a TLS. Sometimes the RH100, it might actually be birds. It might actually be essentially noise. It might be something. So part of my PhD was using terrestrial LiDAR data over French Guiana. Sorry, actually, no, ALS, airborne LiDAR data over French Guiana. And the researcher who had commissioned the study did actually find quite a bit of noise in the first surface, because yes, they did have like flamingos flying over the plot. And so it's kind of standard that folks were looking at like the maximum height of a plot. They might not use the RH100, they might use the RH98 or the where the signal's hitting in the 98th percentile, or the RH95. And so that's just one of the reasons why I picked RH98. Flamingo story. Seems to be sharing, but I could stop and reshare. I see it. All right, let me just reshare. Screen. Sure. Okay, Laura. Hope it works now. But so yeah, there are reasons why people might say, all right, I don't want like the absolute top of the canopy. I might want, or the RH might give us a better estimate for where the true top of the canopy is, or like the true heights. And again, why do we care about heights of trees? Bunch of reasons. In countries in the tropics that are implementing schemes related to REDD+, where they're getting carbon credits for forests that are being preserved, height is usually a predictor of biomass. So generally speaking, if you have a really tall forest, it's going to have more biomass, more carbon than a short forest. And so there's some really cool stuff. Or I work for a timber company and I'm trying to find where the largest stands of tree, the tallest trees are that have more lumber to extract. So yeah, so the root mean squared error is basically kind of telling us, the how, how good or bad our residuals are. This observed and predicted, the models predicting the heights and the observed is based off of the GEDI. And I guess the other thing, I'm gonna do two things, so I'm probably gonna go for just a few minutes. Apologies. But if you click on that graphic, you can actually pull it out. You can also see the fit of the regression, and fits pretty awesome. So, by the way, Ujaval's original script is focused on biomass. I was like, let's do height, not biomass, because biomass sometimes is like, hey, you stare outside. Ever since I started using GEDI data, I now, since I pretend to be a forester on TV, I now like, all right, how tall is that tree? What would GEDI see? I advise y'all to start doing that. Just, walk around with your friends on campus and like, hey, how tall is that tree, you think? So anyhow, that's the fit. We are gonna do one more thing before we close off. And the other thing that we did here that I just want everybody to see, and I need to move this thing here around, is what are we looking at here?
Variable importance.
Yes, but what are the variables that we're using? Bands from Landsat. So I'm sorry, in the interest of time, I didn't get to kind of walk us all through with the different variables that we're using, but I'm using Landsat bands mosaics that I've pulled out using LandTrendr. Because in my mind, I was like, I'm going to explain that one of the cool things you can do with LandTrendr is generate these awesome mosaics that you can use in other processes like height mapping. By the way, we're almost done, just a few more minutes. But Varun, please tell us more about the variable importance.
Okay, so variable importance tells you which variable is more important in the regression process or in the classification process. So here we can see that CHM has the highest importance here. So this is probably very important in like setting up your classification model or regression model.
Please.
So for each of the GEDI data, it already has like the bands attached to it is like the CHM, DSM, or do you have to complete it yourself?
No. So the only thing the GEDI data in this case from the GEDI L2A gives us is these different RHs, these height metrics. And so what we are doing is we are taking that the GEDI height data and now essentially merging them with Landsat spectral data and then these other data sets that come from other sources. And so just to give a quick explanation, again, apologies for already going over time. Anybody familiar with the FabDem? So maybe 2 years ago or so, a group in Europe took one of the newer DEMs. There's a Copernicus DEM, which is based off of Terasar and Tandem X data. They generated this, so probably a lot of people familiar with SRTM. It's a DM that was captured, as it were, in 2000. But the Europeans, using X-band data, came up with this new DEM called the Copernicus DEM, which is global. And then another group applied machine learning techniques to essentially remove the vegetation from that, because most of the DEMs that we work with, like SRTM and the Copernicus DEM, are what are called digital surface models, or they're picking up the heights not of the actual underlying terrain, but of the first thing it sees. And so this other group came up with a DTM where they've extracted off the vegetation. And then I decided if we take the Copernicus surface model and we take the FabDem, and by the way, the FabDem was based off of the Copernicus DEM. If we take the Copernicus surface model and we take the FabDem DTM and I subtract the two, then I should get a height model, no? And I also noticed that the height model didn't necessarily agree with the GEDI data. Nonetheless, as you can see, and at least for the different areas I've looked at in different parts of the world, but here for Belize specifically, when I take their height model, it still seems to be highly correlated with the GEDI heights. So the magnitudes might be off, but it still seems to be a pretty good predictor. So in this case, and again, apologies, we're just gonna go over a few more minutes, but in this case, I've taken like all the things that I wanted to throw into my model and I've thrown them in, and I get, well, you saw before, a pretty good fit. But I'm sure John and others here at the center might tell you, sometimes the kitchen sink model of throwing everything in is not what we want to do. And so if you have the time, let's do something. Let's go to line, we're gonna do two things. We're gonna comment out line 27 and line 37. And so in line 27, I've taken everything, and then I'll just tell you that I had already previously removed a few of these bands and some of these things and found the better predictors. So I've limited them to predictors that I know are pretty good. And so if we comment out 27 and comment back in 28, comment out 37 and comment back in 38, we're gonna now. Is everybody everybody's following, able to do that kind of? And then this is the very last part of our journey together this morning. I'm gonna hit that run button because I really like that Earth Engine is like that. And the one thing that we note, so now my RMSE has gone from 1.6, it's gone up to 1.8. But guess what? I've used fewer variables. And I'm gonna pop this one open. Well, actually no. Well, yeah. I'm gonna pop this open and I have I had to close the other one before. But my R squared of my regression, my fit, has gone down ever so slightly. And if we look at the feature variable importance, etc., we still find that the canopy height model extracted from that difference between the Copernicus DEM and the FAB DEM is still the most important thing. We find that, well, the spectral bands, say, aren't contributing as much. A very bad person, I've gone over time. The long and the short was, like, what have we been able to do? Maybe it blows your mind or maybe it doesn't, but we have GEDI data covering not everywhere, because the GEDI data also is mainly focused on the tropics, does capture parts of the US, but not like full US, etc., just because of the orbit of the International Space Station. But we're able to take these little samples that we're getting from the GEDI data, which maybe you don't want to see them, maybe you want, well, actually no, looks like I didn't add those in, but we can take these sample GEDI data, take this Landsat data, which we have wall to wall, and we can now upscale it and come up with this wall to wall estimate of vegetation height for a country, or a province, or parts of the world that you're interested in.
What is the sampling density?
John is trying to make my head explode. I don't know the answer to that question right now, but it's yeah. Good question. Anybody online know the answer? No. Cool. We've gone over time, and so the very last thing that I'm gonna say. Let's see. Professor Kusheng Wu, I know he was here a year ago around this very time. He has some really awesome tutorials about different things always being updated. Like when I put the stuff together, it's like 8 hours after you just uploaded a video. Bless you. And Sam Roy at Maxar. He also has this awesome GE community catalog where he adds in great open data sets. So I would encourage y'all to check those out. And if not, I'd just like to say thank you all for making this morning interesting. I haven't had my third cup of coffee yet, but hey, still time. Any questions before we completely close it out, including to the people online? You've been awesome, Laura, and I don't know who else is online. follow me on Twitter. It's my handle right there on the bottom.
Well, after this, there's going to be a lunch for this placement. And if you want to also talk to you after the studio.
Okay. Thanks, everybody.
Thank you.